lot of stores growing up, not a whole lot of entertainment. But one day, we eventually did get a music store. And in high school, I used to play guitar with my friends. We loved to visit this store after school and look out at all the different cool guitars, things we couldn't really afford. And every time we entered the store, we were greeted by the store owner. He'd say, "Good afternoon, can I help you find anything?" And at the time, I thought he was a bit unusual. He never looked you in the face. He'd close his eyes when he was speaking to you. And whenever you made a purchase and you took your item up to the counter, he'd ask you, "What have you got here?" He'd continue asking details about your purchase while feeling it in his hands. Confident that he knew what you were purchasing, he would then retreat to a desk behind the counter to write up a receipt. And on this desk, he had what looked like an overhead projector with a monitor on top. And I got really curious one day what it was he was doing back there and what it was he was looking at. So I peeked around to see what it was he saw. And as he put a receipt pad underneath this device, up on the monitor above, you could see a highly magnified and inverted version of what was down below. So the white receipt pad was now black. The blue lines of the pad were now yellowish orange. And it was then that I realized the store owner was legally blind. And this device, it was a critical element in enabling him to run his business and operate by recording transactions. And this one single task was no trivial thing. It actually had, so that this device enabled him to do far more than just record transactions. It enabled him to independently own and operate a business as a legally blind person. I'm telling you this because people like this store owner use our products every day, and our whole world is now more digital. It's our responsibility as product designers, developers, and managers to ensure that our experiences are the best user experience for as many people as possible. If we don't, we risk making our products unusable, or at worst, harmful for the people who need them the most. I'm Nate Baldwin, and today I'm going to talk with you about color and contrast for accessible interfaces. I'm a principal product designer at Intuit, and prior to that, I spent 6 years on Adobe's Spectrum design systems team, where I led some work where we reinvented our whole color system to make sure that it was more accessible. Some things that I'm going to share today are what we learned during this revision and how we made our color systems more accessible. Now, when you hear accessibility, sometimes you might think of things like wheelchair ramps, but the reality is accessibility is for everyone. Accessibility is how any human interacts with the physical or digital world around them. Making interfaces accessible improves the overall user experience for everyone. Now, we needed to consider two different topics for the Spectrum team regarding color accessibility. First, we needed to be considerate of color perception, making sure that important colors were differentiable. And then we also needed to be considerate of contrast and making sure that text and components were distinguishable. On the Spectrum team, we conformed to the Web Content Accessibility Guidelines, or WCAG, which offers some basic criteria for these topics, such as not using color alone to convey information, which ensures that people who can't differentiate color can still differentiate information in your interface. We also have to ensure that text smaller than 24 pixels has a 4.5:1 contrast ratio, and text above 24 has a 3:1 contrast ratio. Along with that, we also needed to make sure that user interface elements and graphical objects had a 3:1 contrast as well. Now, this is a great starting point, but for the Spectrum team, we had a challenge coming into this new work. Our dark themes already exceeded these minimums, and we were still getting feedback from users that there wasn't enough contrast. So we wanted to learn more about contrast and why people were struggling to see these elements in dark themes. Now, contrast is the amount of difference that we're able to perceive between two or more objects. With color, this can relate to any of the properties of color, such as hue contrast, saturation contrast, and lightness contrast. For user interfaces, we focus more on lightness contrast. And the scenario that we needed to address was regarding text and its contrast on light and dark backgrounds. So here I have two pieces of text, one on a light background, one on a dark background. Both of these pieces of text have a 4.6 to 1 contrast ratio with their background. As you're looking at the screen though, you may notice that one of them looks like it has a little bit less contrast than the other. And that's kind of what we were observing too. The dark background text had a little bit less contrast. And a few years ago, we had already sort of adjusted for this. We increased the contrast of our dark themes, so text was closer to 6.5 to 1 contrast. This was the one that we thought was better, but we were still hearing feedback was not enough contrast. And what we were dealing with and observing at this point was called contrast polarity, right? Why is one less easy to see than the other, even though they have the same or different measurements? And contrast polarity, dark text on a light background is negative contrast polarity, and light text on a dark background is positive contrast polarity. And studies show that people may be more sensitive to contrast in a negative contrast polarity setting than on the opposite, which would explain why users were still struggling to see text in our dark themes. The problem is our current WCAG formulas don't really account for this difference in contrast perception based on polarity, right? They're more a measurement of the difference in physical lightness. But what we were starting to learn is that contrast is not physical, it's perceptual. Contrast is not equal to the measurable difference between lightness. So I want you to watch this screen with me closely. After a little while, you'll start to see some text slowly come into view. In big bold letters, you'll see this. Now, if we continue watching the screen for a little bit longer, you may start to see some more text come into view. This one says, before you can see this. So here what we're seeing looks like I've got two different pieces of text transitioning in at different times, one before the other. But I can assure you, both of these pieces of text transitioned in at the exact same time and at the exact same rate. So why would we see one piece of text before the other? This has to do with contrast sensitivity. Our visual systems are more attuned to seeing contrast in larger objects than they are in smaller objects. Let me show you this another way. Here what we're looking at is a chart with vertical stripes of black to white gradients. From left to right, they get smaller and closer together, demonstrating an increase in spatial frequency. And from the bottom to top, they go from pure black and pure white all the way up to a mid-tone gray. And as you look at this visual, I want you to try to see where those vertical lines disappear near the top. They don't make it all the way to the top. Some of them start to disappear sooner than others. And if you try to see what kind of a shape that makes, where that threshold of vision kind of disappears for you, it follows a bit of a curved shape. And this curve is called a contrast sensitivity function. The average sighted person generally follows this type of a curve. And this is the threshold at which things become invisible. What this helps to illustrate is small elements like text need to have a higher contrast in order to remain visible, and larger elements, not so much. And some people have decreases in their contrast sensitivity. For folks who have multiple sclerosis, their overall contrast sensitivity is a bit diminished, but they can still see small elements at higher contrast. Now, comparing that to people who have cataracts, their sensitivity is greatly diminished. It completely drops off before they can see those smaller elements. So for someone with cataracts, not only would they need higher contrast text, they'd also need larger text in order for it to be visible. In effect, contrast is essentially a function of spatial frequency. So size and relative proximity affects our perception of contrast. And this reflects what we see in the WCAG guidelines, right? Small text needs to have higher contrast than large text. And this got us thinking. There are a lot of conditions and scenarios that could result in a lowered contrast sensitivity. So could high contrast improve the accessibility for everybody? Or are there scenarios where somebody may be negatively affected by high contrast? And what scenarios might those be? This led us to learn about photophobia. Photophobia is an extreme sensitivity to light. Light can actually hurt somebody's eyes or can cause migraines. For people who suffer chronic migraines, it can actually be induced by their migraine. And we initially thought our dark themes will solve all the problems for people who have photophobia, right? There's less light, so less likely to cause eye strain or headaches. But this didn't answer the question about contrast. So we did a little bit more digging, and we started to learn that people with photophobia are also more likely to experience optical glare. Optical glare happens when a light source is more intense than the surrounding light. That intense light scatters inside of our eyes, causes a blurring or starburst-like appearance. So here what we're looking at is a demonstration of what optical glare might look like with high contrast text on a dark background. But also, more than just folks with photophobia, optical glare can be affected or can be experienced by anyone, depending on their environment or the adaptive state of their visual system. What do I mean by the adaptive state of their visual system? Well, our visual system has a lot of different adaptations to help us see the world around us based on different environments. One of those is called dark adaptation, which you may be well aware of. It happens when we're transitioning from a really well-lit environment to a darker environment. Our pupils change size, our photoreceptors adjust their sensitivity. And so looking at this visual, we're inside of a cave, right? We're looking out toward the entryway. At this point, we're looking towards the really bright light, and we're in a light-adapted state. The cave around us is dark, but we can still make out the sky, the waves, the beach. Now, if we turn our field of vision towards the darker area of the cave, our visual system would adjust, pupils grow, photoreceptors adjust their sensitivity. So now the darkness of the cave we are adapted to, and the light coming from the entryway is more intense and causes optical glare. Okay, why am I telling you this thing about caves? As we learned about optical glare and sensory adaptations, it became clearer to us that anybody could be in a situation or scenario where they're experiencing optical glare in our dark themes and may need to lower the contrast, such as somebody using our product in a dimly lit room or video editors in darker studio spaces. Learning this, as well as much more about contrast and the visual system, led us to our biggest takeaway, which is that accessible color is color that adapts to people's unique needs, whether those are permanent, situational, or environmental. Some people may need higher contrast. Some people may need lower contrast. Some may even need to adjust the brightness or the saturation of the colors on their screen as well. But at the time we made this realization, there weren't any tools to really help us approach that. How can we make a color system that does enable people to change the contrast or change the brightness? And with a little bit of help from my team, I created Leonardo. Leonardo is an open source color generation tool. It generates colors based on desired contrast ratio. So now contrast can become a variable in the equation, essentially letting users or you define a contrast that you want out of a color, and it'll spit out a color that matches that value. Leonardo also helped us to define a framework for our color system. Here we're looking at the light theme for Adobe Spectrum. And at Adobe, we had about 100 different products across the globe. A huge amount of people were going to rely on our color system to build accessible interfaces. So we needed something that was predictable, scalable, and simple. So looking at this, we can see that our colors are numbered from 100 to 1400. progressively increasing in contrast. So 100 is the lowest contrast, 1400 is the highest contrast. And each color at those numbered increments has the exact same contrast ratio. So blue 400 has the exact same contrast with the background as yellow 400 or green 400. And this helped our teams to choose color and contrast independently from one another. Since our colors are based on contrast, our dark themes take on an inverted appearance. What you see here are 3 officially supported Spectrum color themes. We also had 3 legacy themes of a total of 6 we had to support. But this system enabled us to create easy to use and easy to remember guidelines for the entire company, such as colors numbered 900 and above can be used for text, regardless of color, regardless of theme. Leonardo also provided a framework for us to implement a fully adaptive color system. What you're seeing here is a proof of concept of Spectrum's adaptive theme. An end user could change the brightness, contrast, or saturation, and the colors would be regenerated in real time. As a quick disclaimer, I'm no longer at Adobe. I can't talk to if this is going to get in our products or when, but I can tell you that you can build something just like this for your products today using Leonardo. We also made a point to have better support for Windows high contrast mode. This was separate from the color-specific work, but it became much more apparent through our research. All right, now that we've covered contrast, the next topic that we needed to focus on was color perception. Approximately 300 million people worldwide have a color vision deficiency, and most of them don't even know it. What you see here is a derivative of the Ishihara plate test. It's a standard test used to identify if somebody has a color blindness, as well as what type. It's a circular shape filled with hundreds of smaller circles that are strategically colored to show a hidden message that says hi to anybody who does not have a red-green color blindness. So color perception and color identification is really important when we consider how we use color in Spectrum. Now, WCAG already states don't use color alone, which we didn't. But for Adobe, we wanted to ensure that important colors were still identifiable by as many people as possible. Now, up until this point, we used simulators to find colorblind safe colors. In fact, that's kind of the recommended standard in the industry. Right? Any article you read out there about how to do this is going to say something about looking at simulators. But we recognized a flaw in this approach. I'm going to demonstrate this looking at these 2 colors through a few simulations. So this first one, the colors take on an orangish brown appearance. One is clearly lighter than the other, has a little bit more saturation. As a designer, if I'm looking at these and asking myself, are these 2 colors differentiable? I might say, yeah, they look different enough. I can tell one over the other. Now let's look at the same deuteranopia through a different simulation. Now in this simulation, they take on an olive green appearance. The lightness is a little bit closer together. Saturation is about on par. Here, I don't know. They might not pass. Kind of depends on who you speak to. And then this last simulation, same 2 colors, same color vision deficiency. Here, the colors are nearly identical. So how is it that these same 2 colors could get the response of it's safe to use or it's not safe to use? This is because simulators vary in how they display colors. Essentially, we're just looking at this and guessing. And this had us asking ourselves, if we know that subjective color analysis for contrast is not acceptable, right? We can't just look at some colored text and say, I can read it, somebody else sure can, right? How can we say that this approach is anywhere near acceptable? And for the Spectrum team, we couldn't. It was not an acceptable solution. Color analysis needs to be objective, not subjective. We can't just look at simulations and presume to know whether or not somebody else can differentiate 2 colors. So we set out to look for a more objective, scientific approach for analyzing our colors. And this led us to learn about color difference formulas, in particular, the delta E color difference formula. This is a perceptually based formula, so it measures the difference in color appearance. It was invented for color reproduction, but it does have a lot of value in interface design. And what it does is it provides us with an objective measurement for that perceptual difference. In this case, for a normal-sighted user, the delta E is 70 between those two colors. We realized with a little more color science, we could just convert these two colors to all of their simulated counterparts, calculate the delta E color difference, and then we'd have a better idea of whether or not two colors were safe to use. And we built this functionality into Leonardo as well. So this is on Leonardo's web interface. And what you can see are the two colors that we want to test on the left. And on the right, there's a table with all of the simulated counterparts for those colors, as well as the calculated delta E, or color difference, and a status of safe or unsafe. So here, we could now objectively determine if these colors were safe to use or not. This was great for deciding which colors to use for our semantics, errors, validation, but we had a bigger problem ahead of us. A lot of Adobe's enterprise products use data visualizations, many of which display categorical information. For example, this donut chart demonstrating a breakdown of traffic by operating system. And categorical colors rely heavily on color to communicate information. On average, our products displayed up to 6 different categories, so we needed 6 different colors. And we needed those colors to be identifiable to as many people as possible. So we did a little bit of math. If we have 6 colors, and we have to measure the difference between each pair of unique combinations of colors, that's 15 combinations that we need to calculate. There are 5 different formulas for 4 different color blindness types, as well as contrast. And since we're testing contrast, we also need to be aware of the 6 different themes, which have different backgrounds. This gave us 450 total individual calculations against these colors, assuming that they all pass, which of course they won't. Once a color fails, you have to do this all over again. So we set out to build a better solution that would help us automate this process and also make it a little bit more iterative. In Leonardo, now we can paste all of the hex codes from any one of our themes, in this case our light theme. We can select parameters that we want to enforce, such as which color blindness types to support, if we want it to have a 3:1 contrast with the background. And then what Leonardo does is it cycles through those colors and runs all the simulations and the calculations against those simulations and gives us up at the top a set of generated color samples. That's a list of options to choose from that all meet our criteria. Then, as designers, we can look at these colors and lock in the values that we like. And then once we've locked them in, we can continue cycling through, choosing different colors, and building a palette that is objectively colorblind safe. With that new functionality in Leonardo, it took us less than 30 minutes to create 5 to 7 palettes for the team to choose from. And in an afternoon, we came up with this 6-color set for our categorical data visualizations. This gave us an objective scientific approach to creating and selecting colorblind safe colors. By the end of this work, we had an adaptive color theme. It was an open door for end user personalization, so they could adjust the brightness, contrast, and saturation as they needed. We had colorblind safe colors that were generated from themes using objective measurements, and we had a whole new product, Leonardo, out of it. But above all, we learned that accessibility is for everybody. Also that contrast is not physical, it's perceptual. And it's a function of spatial frequency. So the size and the proximity of objects affect how visible it will be. That accessible color needs to adapt to meet people's unique needs. Some may need higher contrast, some may need lower contrast. And we learned ways to make color decisions a little bit more objectively. But the biggest takeaway from me was what I personally learned, which is why I created colorandcontrast.com. Learning about color and contrast in our field can be really difficult. There are a lot of articles and resources out there, but nothing that really covers the gamut of human vision and how it affects user interface design. So I pulled resources from art, design, optometry, and color science, and I put everything into simple, defined terms. Everything has cited resources with interactive examples, which is very helpful for some of the more complex things, like the color opponent process. There are also insights for each topic regarding how it relates to user interface design. So not only can you learn about these things, but you can quickly see, how does it affect you? What are some actions that you can take to accommodate for or account for some of these topics? This resource is for anyone who wants to learn about color and how it affects user interfaces. And it can also serve as a jumping off point for anyone who really wants to dive in and learn even more. Well, I hope that you've learned something today, and I hope you're inspired to make more accessible color palettes for your products. Thank you very much.
Got some questions for you.
All right.
All right. How can we best advocate for accessibility in our products when business stakeholders may see this as bloat rather than a necessary feature?
That is such a complex question to answer. And I think every organization's a bit different. One of the things that I've seen is really advocating individuals and individual teams for what they can do. If you can't get an entire organization to move forward, having individual advocacy is really helpful. Like, what are the things that you as an individual can do? If you're an engineer, are there things that you can do when you're building components to make sure that there are accessibility features built in? If you're preemptively thinking about certain things like how to support Windows high contrast mode, there are ways that when you're writing CSS, if it's a web application, that you can do it that way to kind of help push things forward as you're advocating. But it's
evangelize within, right?
Yeah.
Find the people that care about it the most and rally, basically.
Yeah.
Yeah. What tools do you suggest using to check that sites or apps meet accessibility requirements?
Yeah, there's a lot of different ones out there. I don't even know where to start, because there's a lot tools that can analyze for accessibility that are different from just color. There's ARIA labels and things that they can read for. Those ones I'm not as familiar with, but I think Stark may have some good tools out there. Chrome's even been building into their developer tools. When you're inspecting, you can sometimes see if text has an appropriate contrast ratio. WebAIM, I think, as well.
Yeah, I think there's also webaccessibility.io, I believe, is one that's all provided by Microsoft to run full accessibility on your sites. So I'm sure we'll provide some resources for you there.
Yeah.
How have you learned to understand your users' problems more? That is, do you focus on scientific studies by a particular research institute, or is it more based on user interviews?
Yeah, that's a really good question. So a lot of the stuff that came up for this particular set of work was coming from our users. For our design systems team, it was a centralized team for a pretty large organization. So we didn't really have access to do a lot of user research on our own. So we relied really heavily on products that were doing user research, insights that we could get from them. And that's really what led us down this path, was hearing some of the things that we'd been doing and some of the problems that they were having. So our approach was, if we can't have access to doing tons of user research, is how can we have the broadest impact, which was looking at existing color science. Because there's whole fields of study that have been looking into this for decades. And it's like, we can really leverage that as long as we just dig in and find the right resources and try to kind of up-level that into our realm. So, yeah.
Wonderful. Do you test with colorblind users on any kind of regular cadence, or do the calculations hold true for all users?
Yeah, that's a really good question. And user testing, I think, is really paramount there, because all of the color science that is out there, the math formulas, even the delta E's, the way that we calculate simulations, calculating contrast, it's all it's all going to change based on individual users and their environments, right? Depending on the type of monitor they have, or whether they're looking at their phone versus, right, a Dell screen, that's going to affect how color appears to them. So we've got like a best guess scenario, but we still fall back to some of the other guidelines and criteria, like, again, not using color alone to communicate information. That way we're trying to facilitate the color difference for as many people as possible, knowing that there's still gonna be people that won't, and we've got answers and solutions for them.
Yeah, that makes a lot of sense. So, context. You get a little context first.
Okay.
Intuit is a huge company with a very high levels of design maturity. For smaller teams, smaller budgets, how do you measure your impact to continue the investment in accessibility?
That's a really good question. I'm not sure I know the answer to that one. I have been at larger companies, but at smaller sizes, demonstrating the impact, I think, comes back to user empathy if you can. Like demonstrating that if you can access to, usually marketing teams have a really great idea of your demographics. And if they have data on the different types of people that you serve, you can do a little bit of research with them to help up-level like what types of users you have, the fact that people are different and have different needs. And even just showing them, pulling out a really ugly monitor that does not have, full gamut support and its color settings are all off, pull up your site on that and just say, look at this, like, this doesn't work. And if you can kind of help them understand that things aren't going to appear the way they think they're going to appear, and to customers that they actually rely on, then that may be a helpful approach.
Yeah. If I may add a little bit of my experience, when it comes to accessibility, I didn't get really deep into it until I actually tested the product that I was designing for accessibility to really truly understand where we were failing, what we were passing. Then you can really dig deep into the problems you want to solve. And as a startup, as a smaller business, being proactive and testing your own product in that vein, I think will get you leaps and bounds more than I need to do this for compliance reasons, or I care about my users and I want to serve them well as well. But last question, how do you manage color needs versus brand needs when a company has a brand palette they are pushing, but one which was created without consideration for accessibility and digital interfaces?
That's such a good question. Yeah, I'm actually dealing with that right now.
You have good questions.
Yeah. So much of that is actually, like, I think, a soft skill. It's about fostering relationships with those teams. Like for us, we're building up that relationship and trust with the brand team to ensure that they know, like, we've got your back. We want you to express your brand, but we want to make sure that it just kind of gets nudged in the right directions where it needs to be nudged. It is kind of tricky. And I think that that's the better approach, right? You could just say, well, no, we've got our UI colors and that's that, and they're different from brand, but it really helps everybody out if you do start to have those relationships and those conversations and educating them on how those brand colors will appear in the context of a product and how that affects things downstream. Because, right, they're typically thinking about the brand, which is like at this really high level. And when you pull it down to the nitty gritty and the implementation of your product and show them, how it can affect things positively or negatively, then you're kind of helping educate them along the way. And
yeah, absolutely. Can we give Nate another round of applause? Thank you so much, Nate, for sharing that. Thank you. Case study with us.